Alright, so last time y'all were kind of crushing it. Like when we went to the board and y'all were doing problems, we did good. So all you owe me right now is your daily check for 4-2. So 4-2 was adding or subtracting polynomials. So I would like you to simplify the this. Go! Okay, that minus that. Write it out, show your work. Don't just have a final answer, please. Have a little bit of something to back it up. Y'all do that. I'm going to grab your multiplication charts because I forgot that in the last 2 days.
So on here, so on making, is it possible to combine these two square root of 2 and square root of 6?
Nope. Exactly.
Okay, so I can get that right. Alright. I'm still working.
No way. See? All right. Who wants some number trees? Here's a dead tree with numbers on it. Here's a dead tree with numbers on it. Here's a dead tree with numbers on it. Yeah. Okay. We even splurged for color so that you know where your perfect squares are. Remember those from first semester? You hear anything about trays?
I'm still working.
Oh yeah. And if you lose yours, which sometimes happens, I will leave them in the back. That's not licensed to just ditch them. But if you ever lose yours, that's okay. You know how many people have been on Snapchat or Be Real and I photobomb them standing behind them? It's so fun. Okay. Everyone get there? Anyone still rolling? No? Okay. So, what was the first stage, given the very, very first thing in here that should pop out at me and go, oh no! Okay. I'm subtracting, not adding. So I need to make it an addition problem by subtract 12x squared y. Oh wait, no, xy squared. I should subtract 18xy. Now you don't have to do this. If you know to subtract this and subtract that, go ahead. That's how the book sets it up. I just know that I screw up negatives if I don't take care of it right away. And then plus 6x squared. Now, I don't have to rewrite this. I can just use my boxes as is. I am going to, just for sake of clarity up here. Negative 9xy plus 4y squared x minus 6x squared. Now what? Turtles with turtles, giraffes with giraffes, right? But you might need some form of organization to it, which is why I usually do. I ran into a plus or minus, chop it. 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 I break mine up so I can just sort my Legos, sort the boxes that go together. And we start at the beginning and ask, do I have any other xy's? Now, I don't have to write out the next line where I put them together and then do the operation. We're okay to just go straight forward if we need to. But if I have xy's that go together, then I'm going to do this xy with this xy. If you owe me 9 things and I'm dumb enough to let you borrow 18 more, now what? Negative 27 xy's. I go on to the next thing and I say, do I have any other y squared x's? This is kind of a trick question.
Y squared x's. No.
Yes.
What?
What makes a like term? Remember our rules. Same variables, same exponents on the same variables. Anywhere else in here do you have an x with a 1 and a y with a 2?
Mm-hmm.
Yeah, we do. It's the difference between first name then last or last name then first. They're still the same critter. If you see a dog walking backwards with sunglasses on its butt, it's still a dog. Okay? They still have 2 y's and an x. 2 y's and an x. They do go together. So I'm going to turn that into 4 things minus 12 things is negative 8 things. And you really get your choice if you want to call it x y squared or y squared x. I'll take both. They're the same thing. I personally put them in alphabetical order because that's how most bigger polynomials are later on. And then I've got this many x squareds and this many x squareds. Those go together. Thankfully, I distributed because negative 6 things plus 6 things, bye-bye, goes away. So, what I'm looking for is, did you, step 1, that was not supposed to be a highlighter. There we go. Step 1, did you distribute or at least remember to subtract? You got the signs right on the back half. Because that's going to domino effect into the rest of it, right?
Yeah.
Then, given what you had, did you put the xy stuff together correctly? Did you put the xy squared or y squared x stuff together correctly? And I know that it's not written there, but did you put your x squared stuff together correctly? So I'm looking at, you got your signs right on the back half. The 3 terms of the answer, one of them is gone because they canceled out. And then I'll leave one floating for, I did all that, but I did something dumb like 4 minus 12 is 6. Okay? Or I got my 2x, like 1 off if you set these as 2 separate things, but you still have your x squared term is gone, you still have your negative 27 xy kind of thing. So the 3 terms for your answer, 1 for some work, 1 floating for the whoopsie. Okay? Go ahead and mark it. If you're not sure, ask. There are some of you that I am now going through and checking all of your stuff because you have been very untruthful thus far in the year about these.
Did I get 2 out of 5 or what?
Oh,
I don't know what I did.
you added a negative 1 to all of them instead of multiplying a negative 1 to all of them. And then that would have goofed this guy. So that'd be 1 off, but then you also separated those 2. I'd call the 3 out of 5. Yes, sir?
Did you use my answers for y2x and 12x y2?
They're the same critter. Remember that in multiplication, order doesn't matter. If I say y times x versus I say x times y, they are still the same thing. Okay? That's why I said if you left those 2 as a separate thing, that is its own part of our points here. Okay? Yeah, that was, I'll admit, that was a little dirty, putting that in there, but I tried to hammer on that definition and those 3 rules of what is or is not a like term. Okay? Now, you should have some space, right, on the back of progress check 1. We are not going to do progress check 1, but right in front of 4.3, you got a big old blank page. We're going to do some notes there. The first thing you're going to do up in the corner, you have a multiplication chart in front of you. Don't you dare touch a calculator. You got a multiplication chart in front of you. Don't you dare use a calculator. We're going to go old school. I would like for you to multiply together, pour favor, 2, 3, 5, 1 times 4, 6. I would like you to old school multiplication.
What are we doing? Just in the back.
No, on the blank page in front of 4-3. You got the multiplication chart in front of you. Same as a calculator. I want to see if you remember the process for this. Okay. Oh, yeah. What'd you do in math today? Basic multiplication.
So if I remember multiplication, I got 30 right here. So do I place the 3 over there?
Yes, you do.
Okay, because I remember
Yep.
once we did like 9s and stuff.
Yep. Let's see if we remember.
Did I get it?
No. Well, try something. You ain't done. There's 2 more lines.
No. Is there?
I want to see what y'all remember.
I don't remember anything.
6 times 1, 6 times 5. I think I did it.
Uh-huh. Very close.
4 times 1.
What did you need to do to start this line?
What? What are you talking about? I think I put 0.
Talk to your boy. Talk to your boy.
Okay, I'm gonna tell you right now. So, then you go like this, and then you plus, and then you go like this.
So this times this, add this.
What?
You need 6 times 1 is 6. This is 30. Put a 3 here. 6 times 3 is 18. 18 plus 3 is 21. 6 times 2 is?
12, 14.
Okay, put a 14 at the end.
Is this correct?
That's it?
I think it is.
I don't know how to do that.
I think the process is right, but it, yeah?
Check me out.
No.
What? How?
Okay, you need to talk to Tegan.
Why?
Because you both did the right process. One of you goofed the multiplication itself. Like one of the numbers. You got the right process. It's just you might have goofed the multiplication itself.
Wait, 6 times 1 is 6.
Oh, we forgot something. We forgot something oh so critical on this line. And then?
And then what?
You don't just multiply it by 6. It's a 46.
Yeah, that's what I did. I got 66. Oh my god.
Okay, that looks like what you had. Right? 146 at the end? Okay, those two got it.
That's what I was doing. What?
You forgot something real critical on that second line. Okay. Wait. Mr. Sullivan made me do elementary math and now I feel bad. All right. No, we just forgot stuff. Okay? I'm trying to ram home here for you. As soon as you got calculators in middle school. Oh, no. It was something super small, dude. Okay? See, that light bulb is what we're looking for here. If you would, do you remember that you're going to take 6 times 1? 6 times 5. Because it's 30 and I don't have room in this space for 30. So I put my 3 up here because it goes into the next place value. Then, green, get back here. 6 times 3 is 18 plus 3, because there was 3 more there. I put the 1 here. I'll put my 2 up here. 6 times 2 is 12. 12 plus 2 is 14. Now, there's another line, right? We're just bringing it back. We're just bringing back the old stuff. Okay? Do you remember that now when I take 4 times that stuff, it's not 4. Isn't it 40? It's 40 times that stuff. This is in the 10 spot, isn't it? I ain't taking 4 times stuff, I'm taking 40 times stuff. So in order to make sure that I start in the right place value, I need a 0 as a placeholder. Okay. When I said a couple of you were really close, you forgot something critical on the second line, you forgot 0 as a placeholder. Okay. Then I say 4 times 1 is 4. I say, where's red? 4 times 5 is 20. 4 times 3 is 12. 12 plus 2 is 14. 4 times 2 is 8. 8 plus 1 is 9. And then, because the whole reason that I was putting these little numbers up here is because I want to keep things in the correct place values. Because 40 times 1 is 40. Okay? That's why I have this in my place value column. Now you're going to add them. I've got 6 here, 4 here, 1 here, 8 here, 10 there. You had a 107 something, dude. Either that or your 8 is just really, really bad. Okay? All right. So, the reason I bring this all back is because I want you to know that everything we're about to do today, you have done before. You just probably didn't do it with letters and numbers.
So it's the same thing, just with
Okay, now, I want to show you something. Oh, you. I'll put this down here. Okay. The whole lot of you are in biology or have taken biology, right? You remember Punnett squares?
Yeah, we just did that. Oh my god. That's horrible. Terrible.
Actually, it wasn't that bad.
I'd rather do fractions than squares.
Cole made it simple for me when he said we did
So there's
Okay. There are different ways to learn multiplication because what you just did was called distribution. You've been doing distribution of polynomials by place value since you were in elementary school. They just didn't call it that. The box method of multiplication says, well, 2 times 4 is 8. 4 times 3 is 12. 5 times 4 is 20. 4 times 1 is 4. 6 times 2 is 12. 6 times 3 is 18. 5 times 6 is 30. And 6 times 1 is 6. So here's what you do. You add another column and rows. Like terms are always going to be on diagonals. On this diagonal is my 1's place value. On this diagonal, 34. Oops, I only have room for a 4. So you go and put a 3 in the, not that column, next column over. And then I would combine like terms again. And I'd say these go together. 20 plus 18 is 38. 38 plus 3 is 41. I'll put my 1 right there. I don't have room for 40, so I put my 4 over here. 12 plus 12 is 24. 24 plus 4 is 28. I don't have room for my 20, so I go to the next column over. And I'll put a 20, or in this case, 2 over, whoa. Baby got back. I'll put it back here, and six plus 8 was, oh no, sorry. That was part of my column. 8 plus 2 is 10. Okay, so you've done this before. You said it was a window method? What they call it? Okay, so some of you might have done this before. What was it, 23, 51, and 46? Okay, next to that problem. Next to that problem, I'm going to show you something that is very similar to what we're going to do today. That is not 46. What it really is 40 plus 6. Right? Well, then move up here and just don't be a turd with Sean. Okay? Y'all, what place value is that 2 in? For anyone who's actually listening and not just staring at Leighton. What place value is that 2 in? Thousands. This isn't 2351. This is 2,351. Right? That should look familiar. You've broken things up by place value like this. Remember when we did distribution? If you had like a 5 smashed up on parentheses, 5 times the x, 5 times the 3, something like that. Watch what happens when we go ham on this. 40 times 20,000, or sorry, 2,000, is 8. 1, 2, 3, 4. 40 times 300 is 12,000. Watch what happens piece by piece. Here I get 2,000. Here I get 40. See how we still have a 6? Distribute that too. 6 times 2,000 is 12,000. Six times 300 is 1,800. 6 times 50 is 300. And finally, we're running out of colors. Got to go back to this. I get 60. Oh wait, that's just a 6. Whew! That was close. If I add all of that up, take a wild guess what I'm going to get. 108,000. Okay. You have been distributing really big things since you were first taught how to do this in elementary school. Okay? So everything that we're going to do today, you have done it before. Now's where things get wild. Ready? Now we're going to do that. And it looks super crazy until, isn't this what I just wrote, except there's X's instead of zeros up there? Because 10 to the third is 1,000. Thousands place value. 10 to the second is 100. This is the hundreds place value. 10 to the first is 10. This is the tens place value. 10 to the 0 is 1. This is the ones place value. You have been doing this with polynomials your entire life. It's just they were all 10 to the something. So, here we go. I hope y'all got those multiplication charts ready to roll. Up here, they're going to use algebra tiles, as I understand it. No one here has really done that. They don't use it in your elementary schools. So I'm not going to bother talking about it. Instead, I'm just going to go straight to the example. First up, we got to be able to do basic distribution. So we're going to take 5x times 3x to the third. We're going to take 5x times 12x. Now the exponents will change. Does anyone still have their note card from first semester on exponent rules?
Yes. Oh, shit.
Kept falling out my binder, so it's right here.
Well, here we go.
I like that. I don't like that.
Do you remember when I have an x to the first times an x to the third, what I do? 1 plus 3. I have x to the fourth. Okay? When I put a 3x to the third, I don't know why they want us to write it again. When I multiply these together, I'm going to take the 1x here and the 3x's there and say that's x to the fourth. I still need to take care of what's 5 times 3? 15. So together it's 15x to the fourth. Same over here. What's x times x? Yeah, you should. No. X to the second. Remember, there's a little invisible one here, little invisible one here. X to the first times x to the first. 1 plus 1 is 2. What is 5 times 12? 60. Okay. So you know how to do basic multiplication. We reviewed old school distribution. Now we're going to throw a bunch of alphabet soup in with it. Okay. You will need this if you're going to geometry, if you're going to take an AccuPlacer, if you're going to go to tech school, anything like that. You have to be able to work with these expressions. Okay? So when I distribute, 5x is going to go to both of them. Watch your exponential rules. Because we about to start doing it twice. Do you remember what it's called when I have two terms? two terms is a binomial. So they're going to say, use a distributive property 2 times with the first binomial. Would we even know what that means if we don't know what a binomial is? Okay. They're going to tell us that if I have things times things, hey, you can nicely go back to the corner. Too bad. I'm going to take b times b and b times 5. That's what we're doing here. We're starting with b times both of those. Then I'm going to switch and do 4 times b and 4 times 5. I have to distribute both of the things that are in there. And then I'll check for like terms. So if I take, they want us to write it again because they like doing that at the beginning, b times b and b times 5. Well, what's b times b? B to the second, remember, little invisible ones on there. B to the first times b to the first. 2 b's together makes b squared. What's b times 5? 5b. Okay, now do the other one. We've got a 4 times that stuff. What's 4 times b? 4b. What's 4 times 5? Well,
I can't go back there because all I hear is Spanish.
where can I put you that you're not going to be blabbing the whole time?
Right there.
Where can I put you that you're not going to be blabbing the whole time?
Right, you can sit right there.
Like, y'all notice the 4 stooges are split up here to the corners for a reason. Okay. What's 4 times 5? Okay. Then you write it all together. This is why we had to learn to combine like terms first. Look at this expression. Do any of those go together?
Yes.
Which ones? The 5b and the 4b are the same kind of critter, so I got to put them together. B squared, what is 5b's and 4b's? 9b's. And then that 20 is at the end. This is where it's all been leading. And then after we do these, then comes equations with these that we solve. Okay, this is where we had to review everything from last year to make sure you were even ready for this. What's up?
Okay, so if we're going to be ending, but combine like terms, doesn't matter what order they're in.
Okay, now when we went to the board the other day, some of us were writing them in all kinds of goofy spots in different terms, right? I'll tell you that the way we normally want to write them, y'all seen that that display of the different popcorn sizes at the theater, right? You got the little kitty one, you got the little bag, you got the big bag, you got the big Merca bucket, right? We want to do things in, it's called descending order. Who's the big dog? Which term has the biggest degree? That big bucket. Then the bag, then the little kitty box. I want to put things in descending order because it's b squared, b to the first, b to the 0. 2, 1, 0 is normally the order that we like them. Now I'm not going to put this and this because that's not simplified. This is where we're going. So, step 1. I want you to start with just numbers 1 through 4. I know we might be a little bit sketchy on our distribution here. I want you to start with just numbers 1 through 4. I'll do 6 and 7 with you. Okay? What?
Can I go to somewhere else to work? Like,
A different table? Okay.
work and like go, or like whatever, destroy something. I don't know.
Like you just want a quiet spot to do the work? Yeah, just step outside, come back in.
Okay.
I'm not sure if that's what we're asking, but yes. Do problems. Okay. Stooges. When I see you on a phone and not doing a thing, not doing what we're supposed to, we ruined it first semester. Are we going to do it again?
I'm doing it.
Knock it off.
Sean, you played Rocket League? Oh my god.
You play pool like every 5 seconds.
Yeah, but I played and I
He's on
turned it off.
Snapchat 24/7.
Work. The first 4, please. What's up?
I got a question.
Mhm.
So would I do 2 times 5 for this one? And then like
Number with number, x with x. So in the parenthesis goes 5x squared. But then 2 times 5, x times x squared.
okay, so what I now do 3 plus 1 or 2 plus 1? That'd be 3.
Yes. Oh, no, not yet. Not yet. You're trying to jump steps here.
There's more steps.
Okay. Where's... First is I just want you to write out the distribution. You're taking this times 5x squared.
Oh.
You're taking this times 7.
It's like baby steps.
Baby steps. And then we get over here and they take it all away. Okay, so what is 2 times 5? You said 10. So x to the third.
Okay, so if I don't write x, it will get off.
Yep. 2 times 7. And then there's no other x, so I just write my x with it.
So would you always do that? Like,
Yeah.
Always put the imaginary one up there?
Yes. In fact, that might be a good idea as we're getting back into exponent stuff.
Thank you.
Mm-hmm. Who sings that?
I don't know. I just figured it out on a Vine one time and I thought it was funny.
Oh, okay. We should leave it to them.
But it's so much fun because then the mailman just goes, yay!
Yeah.
So I know how to like do this part, but then as soon as I get
So,
to
what's 2 times 5?
10.
X to the first times x squared.
X squared.
No.
Oh,
Remember,
you add. Okay. X3.
2 times 4.
You actually multiply.
Okay, thank you.
That's it.
Stupidity's gonna rub off on me.
I'm missing a step or two. Should I help any young sir?
Okay, so what are you multiplying 2x by?
That one.
This and
Oh.
what's 2 times 5?
10.
What's x to the first times x to the second?
2.
No. Remember, we add
Oh,
exponents.
3.
2 times 7.
14.
So I was right.
Where you said 10x squared.
Bro, 10x cubed is like the same thing.
So when you're distributing like this with the exponents, you just add them.
Correct.
Wait, so what did you get?
I was off. Yeah, what if x cubed plus
I made a T.
5.
No, that's not right.
I made a T.
Let me see that.
It's a little
Thanks.
broken.
Do this.
Hey! Give that back to me, sir. Thank you. I know I
I struggle. This one's good. Man, I need some votes.
Okay. What number's in front of us? Y.
1.
What's 3 times negative 1? 3 times negative 1.
Negative 3.
There you go. Y times y squared.
Which is oh, because there's y.
Yes. Turtles with turtles, giraffes with giraffes. 3 times 4. Y times y. There you go. 3 times negative 12. So negative what?
Oh, that's right.
Ah! Got him. Put it away. There you go. And the y goes with it. Yep. Yeah, just like that.
Great, so you get negative 36g plus negative 12g squared.
Given our leaning tower of Fanta, I'm assuming we're done over there.
I forgot the negative, but yeah.
Come on now.
Negative 4 times 9 is not 13.
Negative 4 times 9 is negative 36.
Please.
Oh, I subtract.
Bro, he's smart like us.
Yeah.
Academic weapon right there.
Yeah.
He's got it correct, huh?
Academic weapon.
Grace, cease vocalizing.
Yes.
Oh, he said it.
Did you say it like that?
Who's last night, Rich now?
And really.
5. 2.
Yes. How?
God, number 3 is hard.
I don't know.
It's all hard.
14.
No, number 2 wasn't hard.
Number 2 is.
Yeah, number 3 is hard.
3 times. I'm all done. Like the guy I drew.
Okay, looks like most of us are there. Okay, when you distribute, you already know how to distribute. We just got to watch out for our exponents. When I take 2x times this stuff, I have to make sure turtles go with turtles. Giraffes with giraffes, there's a little invisible one there. X to the third. 2 times 7 is 14. X to the first, there is no x over here, so I just jam an x next to it. Done. Okay. What I want you to be careful about here, they always start with the scaffold. They're going to put the parentheses and everything here for you. I want you to get into a good habit now. When I distribute, I start and end in that little armpit between the sign and the number. So I know it's a -4 times this stuff. I'm going to distribute a -4. See how I'm going to end in that little armpit between the negative and the 3. So I understand that's a -4 times a -3g squared. How many times have you screwed up a negative in your mathematical career now? Draw your arrows into those little valleys between the sign and the number so you remember it's times a -3. Should be getting -36g plus 12g squared. -4 times -3. Okay. You go back there. Stop flapping your lips or you're going to go sit right next to Miss LaCroix. We'll even pull up a new table for you.
Oh, no, thank you.
And I'm going to give her the dinosaur.
No.
Okay. Come on, Frank. There we go. When I distribute this, watch that I put from the sign to this. A -1 times 5 is -5. And a to the third and a to the third makes a to the sixth. Show the next piece of it. A -a to the third times a positive 6a. Again, there's a little invisible 1 there. -1 by 6 is -6. A to the third with a to the first makes a to the fourth. Show that you're going from a -a to the third to a -3a squared. A -1 with a -3 is a positive 3. A in the third and a squared is 8 in the fifth. Now, going back to what Tian had asked earlier, I personally would not leave it like this because it's not in what's called descending order. Descending order wants large, medium, small. So what would you change if you wanted to wiggle these around? Okay, I would put the big dog out front, then the next guy, follow it up with this guy. That's how I would do it. It's okay if you leave it like that for now. And a little bit faster. Got a -y, that's a -3y squared. Have a 3y by a positive 4y, they already wrote it. Turtles with turtles, giraffes with giraffes, that's 12y squared. That's a 3y with a -12, make sure you say -36y. Okay? You have to be able to put the right things together. I wanted to get those out of the way before sending you on to 5 and 6 because there's a lot more alphabet soup there. Try 5 and 6. Draw your arrows. Remember, you add exponents, you multiply coefficients. Add exponents, multiply coefficients.
So for this one, would there be 2 ones? One for the X and one for the Y, or just be one for both?
1y. Because it's this whole mess times this whole mess. So you're right about the invisible ones. So what is...
So it'd be 4 plus 1 plus 1.
So first numbers, 4 times 2. Remember, those are their own rules. Exponents are different rules.
Yeah.
4 times 2 is what?
6, right? Oh, it's 8.
Then you have an x to the 1 and an x to the 4. And then you have just a y to the 1. So just write y.
Okay.
There you go.
Okay.
Okay. Turtle with turtle, giraffe with giraffe. Okay, those look to be going fairly smooth. If I do this, we get a 8 x to the 5th y. If I multiply by a 7x cubed, number with number, 2 and 7 makes 14. X to the 1st and x to the 3rd makes x to the 4th, and there's a y on there. Number with number, x's with x's, y's with y's. Because see how there's only a x here, but no x's over here. So altogether, there was only one x, so x to the 1 power. Down here, same thing. If I take this times this, 3a squared b squared, there's a lot of alphabet there. But go piece by piece. -5 with 3. A to the 1st with a to the 2nd. Because now we have 3 of them all together. B with b, 1 plus 3 is, or sorry, 1 plus 2 is 3. If you take them a piece at a time like that, see how I'm putting my arrows into those negatives? Negative to negative. So I understand there's a negative AB here. A negative times a negative is a positive. 5 times invisible 1. A times A is A squared. B times B is B squared. A negative times a positive is a negative. 5 by 5 is 25. A times no A's is just A. B times B squared is B cubed. Now, I want to show you if you get stuck. Some of us are a little iffy on the exponent stuff. This is going to help you get unstuck. I'll rewrite this problem here as -5ab times, if I were to rewrite this as 3AABB, remember writing these out longhand when we did exponents at the beginning of the year? It sucks, but it'll get me unstuck. If I rewrote 5b squared as 5bb, like this. Frank, If I multiplied this by this, that's a -5 times a 3 times A, B, B, B. I can write it out longhand. And then just count. Wrong color. I see 3 of each variable, so I write it out like this. I can write that as -5 by -1 by A, B, B. Writing +5 A squared, B squared. If you get stuck, you can always do -5 by 5, A by B, B, B. Okay? Like, do you see how that could help you get unstuck? I don't care if you like it. Would it work? Like, if I'm just so lost because of how many letters and numbers there are up there, I can go back all the way to September and I can write it out longhand like this. Okay? Flip it over, those were just distribution. Now all of a sudden, we got our double distribution, binomials. It just means you do it twice. I strongly recommend that you write over and under arrows. I'm going to take 7x times this stuff, and then I'm going to take 3 times this stuff. Okay? I will do over and under arrows to show that I'm distributing twice. So then it becomes 2 multiplication problems. 7x times each of these. Oh wait, they just want us to write it again. Stop making me write it again. I don't want to. If I take 7x times this stuff and I take 3 times that stuff. There we go. If I take 7x times 7x. If I take 7x times -3. If I take 3 times 7x. And a 3 times a -3. You see how it just breaks up into the pieces a lot like what we were very first doing if I told you to do 73 times 37. Didn't you do 4 things? Right? This times this times that, this times this times that. And then the very last thing was you had to combine like terms. If there were things that went together, you put them together. I'm doing the same thing here, it's just there's alphabet soup with it now. What's a 7x times a 7x? Close.
49x squared.
X squared, right? X to the first times x to the first. 49x squared. What's a 7x times a -3? There you go. A 3 times a 7x. A 3 times a -3. And then I'm going to look to see if any of them go together. Every time I run into a plus or a minus, I chop it up. I look at my boxes and I say, who goes together? X to the first goes with X to the first. You owe me $21, you pay me $21. There are no more dollars, right? Negative 21 things plus 21 things is 0 things. So my final answer is 49x squared minus 9. These two in particular, they're very special in math. We're going to see them again later in this chapter. They're called conjugates. They go together. Conjugate means to go with. How many of you are in Spanish or French? Oof. No foreign language buffs here. What, 1, 2? Okay. Have you ever heard of to conjugate a verb?
Mm-hmm.
It means what goes with it. Conjugates just means things that go together. That's also why years ago jails used to have something called conjugal visits. Google it, not at school. So, all I need you to do for these, I'm going to do one of them, you're doing the rest. Yes.
Awesome sauce.
What's a 9x times a 5x? Close.
Next to the second.
Okay. What's a 9x times a, see how I'm going into that little corner there, positive 4.
36.
Is it x or x squared?
I don't know. I thought it was going to be.
I stopped writing. Which is it?
X squared.
9x times 4.
Oh, wait,
Just
yeah,
x. Then, because I'm done with the 9, I gave the 9x to everyone in there. Now I'm going to switch over here and say, what's 1 times 5x? Yeah, just 5x. What's 1 times 4?
5. Not 4.
1 times 4.
4.
Just 4. And then, do any of those go together?
Yeah.
Now, I like, who was doing this yesterday? Killian was doing this yesterday. When she saw that 2 of the terms went together, she actually drew little arrows like this and said that's 45x squared plus 41x plus 4. She just did little arrows to show that these two came together. It's really tiny, but that's 41. 36x's plus 5x's is 41x's. Okay? If you want to use the arrows to show that, don't have to. It's just another trick that looked cool. The other 5, please. I did distribution, you do distribution. Do these 5, like now. Do these 5 right now. These 5 right now. But I just did one.
Oh, okay.
Bruh. Yes, sir.
So on this one, do I add so on these ones, do I add a, or is it just -4?
-4. Now, these 2 can go together. And I know there's not a ton of room here. If you need to write it off to the side, if you need to put it on a separate sheet, that's fine. Okay, there's not a lot of room here. If you got to get creative with your placement or write your answer off to the side and circle it or something, that's fine. Otherwise, it gets pretty squished.
I just add the, so I just do 4Q.
This.
4PQ, yeah.
Okay.
And now we'll do this guy. Yeah. Don't feel bad if number 12 kind of hurts the eyes. P's, Q's, 9s, and 6s together is just mean. Six plus 4. Oh. You know what, we're probably going to have to do 2 together. Or 12. I bet we're going to have to do that one together just because it's got P's and Q's. Yeah.
What?
So, 10, are you getting the same multiplicative things? Disturbert. This times this times that, and on, combine negative 6a's plus 4a's. Where this can get a little confuzzling is if we don't understand adding terms doesn't change exponents. Multiplying terms does change exponents. And then coefficients and exponents have their own laws. That can be tough. If all them P's and Q's hurt your eyeballs, stage 1. What's 4 P's times 9 P's? 36 P squareds. If I take 4 P's times Q, it's just got to stay PQ. It just doesn't get any nicer. What am I going to distribute next? Careful. negative 3q. Negative 3q. Making it a negative 27 PQ. If I take a negative 3Q times a positive Q, a negative 3Q squared. So, who's goofing signs on these? What I'd recommend before starting then, those boxes that we've been using, they also work here. If I take this times this, every time I run into a plus or a minus. Now, I'm going to show you another way to do this. I think the way I copied it, you got room on the back page here, right? There's a blank page right in front of this. Okay. I'm going to show you the other ways to do this. Where'd you go? I brought up Punnett squares at the beginning. Said most of you have done these in biology. If I took 4p, or no, 9p times, short-term memory bad. What was this one? 4p minus 3q? If I do 4p minus 3q, just like you have like big T, little t for your dominant and recessive traits, didn't I have, get out of here. Didn't I then have a 9p and a, what, just q? Watch what happens if I turn this into Punnett squares. What's 4p times 9p? What's 9p times negative 3q? What's 4p times q? What's negative 3q times q? Okay. For some kids, that visualization is the deal breaker. That's the thing that just makes it blow apart and say, okay, I get this now. Is when they can see the rows and columns. And the fun part about it is when you do it that way, your like terms will always be on the diagonals. Like I tried showing you at the beginning with old school multiplication. The end of this shows us, whoa, baby got back. 36p squared minus 27pq, oh wait, we're combining, minus 23pq minus 3q squared. The ability to organize your multiplication is all that separated kids in elementary school. It's the same thing now. This should get you a 6, negative 4, negative 5y plus 4y squared. This should get you a negative 6y squared, negative 148 plus 47y minus 8. This should get you a x squared minus 1. Do you have the work to back it up? That's 49. I was just double checking them too. No, she started saying it before I got up. Like I was just looking at it, but she got there first. Getting there. I combined. I've already combined my terms. I'm putting the final answer there without the work. You better have the work. Which one are you looking at?
9. What is that? -5.
Did I just not write my 2? God. Yeah, I just plain didn't write it.
Give it to us, man.
Man, what's up?
2 is like 3 sections.
Who to what? Oh, that's a 2. I was writing fast.
9 point.
No. Oh, if we're going to start going off of handwriting, I'll take that into account on your next tests.
That's fine. Marcus, you're done.
Okay. I do want to stop there, though, because we're going to have to do some more practice with this before I really set you loose. And I want to show you different methods, too. There's the box method, there's stack method, there's a cross method, there are different ways to organize this. And I want to show you all of them. Right now, this was just, I kind of call it the spaghetti monster, because it's just a bunch of arrows and noodles everywhere. We're going to show you a bunch of different ways. Well, because then you get your choice. Hopefully we're not going there for a particular reason.